In June 2024, pi, the ratio of a circle's circumference to its diameter, was calculated to 220 trillion decimal places. Our earliest recorded history of the calculation of pi is from China in the early 5th century. At this time, pi was calculated to 7 decimal places. In the 14th century, the Mahadeva of Sangamangara calculated pi to 13 decimal places, and in the early 17th century, Ludolf Valkunen calculated it to 35 digits. Now, by the early 19th century, only 225 years ago, pi had only been calculated to 126 digits. But by 1853, it had been calculated to 527 decimal places. So at what point in its history was pi accurate? Was it accurate when calculated to only 35 decimal places? Or was it accurate when calculated to 527 decimal places? Or was it wrong but useful at that time? Is the calculation of pi accurate today at 220 trillion decimal places? You see, every extra decimal place that is added to the calculation of pi increases its accuracy. Therefore, all preceding calculations of pi are inaccurate. Are they also wrong? This is ToK essay number 5, May 25. Models can be wrong but useful. Welcome to ToK Today. My name's Daniel, and today I'm going to give you a brief overview of ToK essay number 5, May 25. That's the essay about models being wrong but useful, and I'll give you examples of definitions, knowledge claims, examples, and evaluation points for this essay. Now, at the end of the video, I'll also explain some of the potential pitfalls for students writing this essay. We don't want you falling into those pitfalls. However, before I begin, I must warn you that this is only one of the many approaches available for this essay. This is just my interpretation. Other people will have their own interpretations. However, if you do like my approach, my interpretation, you can find out more by picking up the ToK Today student guidance notes for this essay, available from the ToK Today store. They're like a mini textbook for this essay. And ToK teachers, if you want more help supporting your students, you can pick up the ToK Teacher Support Package, also available from the ToK Today website. So in today's video, I'm going to focus solely on AOK Maths, because prescribed title 5 directs us to AOK Maths, and some people can be intimidated by that. But don't worry. Don't worry about being directed to AOK Maths. You don't have to be super good at maths to be confident writing about the ToK of maths. Just like you don't have to be good at football to be a good football commentator, you don't have to be great at maths to be a good ToK mathematician. Secondly, all of the content that I present here about maths can equally be applied to any other area of knowledge. So let's jump straight in by defining or explaining the key terms: models, wrong, and useful. Now, obviously there are many different ways to define these terms, but a dictionary definition will probably not be sufficient. Your definition will need to be meaningful in terms of the knowledge claims that you're developing, and it will need to be linked to ToK concept, and it may be linked to ToK structures. An example of a definition for a model in AOK Maths could be a concept or algorithm, formula, or calculation used to explain, demonstrate, or predict the relationship between integers or variables. Now, obviously, there are many other definitions of models that could be developed, and this is only an example. Now, your definition or explanation of wrong and useful are going to be crucial to your response to this essay. It's important to spend some time carefully crafting these definitions. For example, let's look at two different definitions of wrong in maths. The first is that the model doesn't account for all new conditions or data encountered or produced. And the second definition is the model is incomplete and therefore can appear inaccurate. Now, you will develop a very different answer to the prescribed title if you were to use the first definition rather than the second definition. Now, it may be better to write your knowledge claims before you write the explanations or definitions of the key terms in order to ensure that your definitions or explanations fulfill the needs of your knowledge claims. Let's look at explanations of the key term useful. Here you could consider questions such as useful to whom, and useful for what, and useful in which contexts. You could use the ToK structures to help to develop your explanation. For example, useful for knowledge producers, or useful for knowers, or useful for the knowledge community of mathematicians. Again, the definitional explanation of the word useful that you develop will have a significant impact on the knowledge claims that you can use, and therefore will influence the essay that you can develop. Spend time developing the definitions before you start writing the essay, and develop them alongside your knowledge claims. Now, at this point, it's useful to draw your attention to the command term in the essay, to what extent. And this means that you have to say how much you agree or disagree with the statement in the prescribed title. You have to indicate a degree of agreement. Now, you could use conditions to do that. For example, models are wrong but useful in AoK Maths when predicting future events. But in AoK the Arts, we could not establish that models are necessarily wrong, but they are always useful in producing artistic knowledge that builds upon previous knowledge. So let's now move on to look at the type of knowledge claims that could be developed in AoK Maths. And again, I reiterate that there are many different knowledge claims that could be developed for this essay. These are just examples of the sorts of knowledge claims that could be developed. Knowledge claim 1. The purpose for which mathematical models are used is a stronger factor in their usefulness than their accuracy or wrongness. Second knowledge claim. In application, the knowledge determines both whether a mathematical is deemed wrong and whether it is deemed useful. But in pure reasoning, the knowledge community of mathematicians determines whether a mathematical model is deemed wrong or useful. Knowledge claim 3. The development of an AoK requires that all mathematical models are wrong but useful. Future knowledge development requires the identification of flaws in current models. Knowledge claim 4. Models may be wrong in so much as they are ideal types, and they may be useful in so much as they guide the object and method for the further production of knowledge. Now, I could go on developing these knowledge claims, but I think you get the idea. The knowledge claim provides you with a more focused lens through which to explore the prescribed title. These are just examples of the sorts of knowledge claims that you could develop. Next, we'll look at the real-world examples that could be developed, but we'll do that after this life-enhancing message.
If you want to produce a model ToK essay that is not wrong, but very useful to getting a great grade in ToK, then pick up the ToK Today student guidance notes from the ToK Today shop. Last year, 72% of students who used the notes reported that they achieved a grade A in ToK. The notes are a faster and less stressful way to write a great ToK essay.
And ToK teachers, don't feel left out. We haven't left you out. You can pick up the ToK Today Teacher Support Pack also from the ToK Today website. Okay, let's get on to the real-world examples. And again, there are many, many real-world examples from which you can draw. Once you've written your knowledge claims, you could ask your maths teacher to help you to identify some examples. Now, obviously, some of you may want to make a distinction between models in applied maths and models in pure maths. And if you do make this distinction, then you could look at applied mathematical models in other subjects, such as the natural sciences and economics. The knowledge arguments that I've used all generally agree with the prescribed title that models are wrong but useful. Therefore, my examples also tend to show that models are wrong but useful. Examples of examples that I could use include the example of the historical development of pi over time, as I briefly outlined at the beginning of this video. That's a great example for what is meant by wrong, like at what point is pi considered to be wrong, and at what point was it considered to be correct. Another classic example is Andrew Weil's proof of Fermat's last theorem. And this theorem has been unsolvable for centuries because existing models in number theory couldn't adequately address its complexity. However, Andrew Weil's proof drew on advancements in mathematical knowledge which connected previously unrelated areas of maths. Now, even though earlier models of understanding numbers were incomplete or wrong in terms of solving this specific problem, they were immensely useful in eventually reaching a solution. Other examples could include the problems of applying Newtonian mechanics at very high speeds or in extremely small scales. Other examples could be the non-Euclidean challenge to Euclidean geometry from Lobachevsky and Riemann, and Euler's formula for primes, which was initially believed to be correct but was later shown to be flawed, but nonetheless led to significant advances in number theory. Of course, your knowledge argument may require you to come up with examples that models are not wrong and they are useful, or that models are not wrong and they're not useful. And this is where your definitions of the terms wrong and useful come in. How you define those terms will influence the examples that you can use. Something that's not wrong but is also very useful is your ability to give me a like for this video and a subscribe if you want more support in ToK. And this would also make me very grateful. Thank you. Okay, moving on, we still have evaluations of the claim and pitfalls to go, and then you're out of here to get on with everything else in your DP. So how you evaluate your claims will obviously depend on the specific knowledge claims that you develop. And one of the quick ways to start thinking of evaluations is to use the BLUR's acronym. BLUR, one of my favorite groups from the 1990s. Now, the BLUR's acronym, this stands for bias, limitations, uncertainties, reliability, and subjectivity. Examples of the sorts of evaluation points that I could develop for the claims that I made earlier are as follows. Knowledge claim 1 is the purpose for which mathematical models are used as a stronger factor in their usefulness than their accuracy or wrongness. Now, any knowledge claim that looks at the purpose or use of the model can be evaluated in terms of the relationship between the production of the model and its use. We need to consider whether knowledge, in this case a model, is intentionally produced for the purpose for which it is now being used. And if it is, then we can consider whether use or function is the cause of the production of knowledge. And if so, why are there models that lack usefulness or are misused or are essentially wrong? And knowledge claim 2 is that in the application, the knower determines both whether a mathematical model is deemed wrong and whether it is deemed useful. But in pure reasoning, the knowledge community of mathematicians determines whether a mathematical model is deemed wrong or useful. Now, this knowledge claim may make a distinction between applied and pure maths, but in ToK, the same argument is being made in both disciplines. In ToK terms, the knowledge claim is arguing that the usefulness of a model is determined by human subjectivity. And the concern here is that some people think that maths should strive to operate beyond human subjectivity in a realm of objectivity. Now, whether that's possible or even desirable, I'll leave up to you to consider. Now, knowledge claim 3 is that the development of an AOK requires that all mathematical models are wrong but useful, and that future knowledge development requires the identification of flaws in current models. Now, this knowledge claim takes a very loose and widely applicable definition of the term wrong. Now, if we're going to apply wrong so widely, it becomes very difficult to identify when a model is correct or accurate, or however you're defining the opposite of wrong. Let's call it accurate for the moment. Without the identification of accurate knowledge, how do we know which knowledge to develop in future models? We are stuck with useful knowledge only, and this gives us a very utilitarian approach to mathematics, and, for that matter, any other AoK. Now, knowledge claim 4 was that models may be wrong in so much as they are ideal types, and they may be useful in so much as they guide the object and method for the further production of knowledge. Now, the merit in this knowledge claim is that it describes the role of models in the future development of theoretical knowledge. However, it possibly lacks a real explanation of the link between the ideal type model and the future development of theoretical knowledge. It doesn't adequately explain how a theoretical model can inform future development of knowledge if it has not been tested in the real world. Now, these are just a few of the many evaluation points that you could develop for this essay. The evaluation points that you develop will depend upon the knowledge claims that you write. However, I hope that these examples give you a flavour of the sorts of evaluation points that could be developed. Okay, let's get back to the final section of today's video. The potential pitfalls in this essay title. The first and most obvious potential pitfall is that there is a risk of getting hung up on the maths content. This is whether the mathematical models are accurate, how the maths formulae should be carried out, that sort of thing. Maths talk. The focus needs to be on the ToK rather than on the calculation of mathematical models. So you need to focus on the knowledge issues, such as what could be meant by a mathematical model being wrong, what are the different ways in which mathematical models might be used. Now, a second potential pitfall is not directly addressing the command term. To what extent? Essays that don't indicate a degree of agreement or disagreement with the statement are less likely to be assessed in the higher mark bands. Now, if you want more help or support with this essay, remember to check out the notes and coaching and feedback options, which are all available on ToK today. Thank you so much for watching, and I'm wishing you the best for writing your ToK essay. Stay ToK-tastic, my friends.